Physics 9702, May-June 2016, Paper 12. Question 26. Which statement is an example of the diffraction of light? Option A. The addition of the amplitudes of two beams of light which are in phase. So here they're talking about two amplitudes are being added when they are in phase. So here they're talking about constructive interference. So this is not the option. The change in direction of a beam of light when passing from air into water. Air and water are two different mediums. So when beam of light passes from one medium to another, it will bend. In this case, they're talking about refraction. That's not the answer. Option C, the separation of a beam of white light into a spectrum of colors using a prism. So white light is being spread to the 7 colors which are, in this case, they're talking about dispersion. The spreading of a beam of light as it passes through a small hole. So when light passes through a small hole, they will spread like this. So you can see a plane wavefront when passes through a hole forms a circular wavefront. So that's diffraction. So the question says, which statement is an example of diffraction of light? So in this case, the correct answer is option D. Question 27. Sound waves of wavelength lambda are emitted by a loudspeaker and passes through two slits P and Q. So we have two slits P and Q. Through this, we have sound waves passing by. So when we have two slits and waves passing by, we have interference. So interference is taking place. Two sound waves from the slit meet at R. So now the waves from P and Q meet at this point. Sorry about my diagram, so it will be a straight line. What is the condition for an intensity maximum to be detected by a microphone? At R. So intensity maximum is taking place at this R. That means there is a constructive interference. Let's see the option A. The amplitudes of two waves at R must be the same. When interference is taking place, this is not a necessary condition that the amplitude should be same. Amplitude can be same or cannot be same, but still you can have constructive interference. So this is not the answer. The distance PQ must be smaller than the wavelength lambda. That's nothing to do in this case. The two waves from the slit must have traveled the same distance. So they're saying the waves should have traveled the same distance. If they have traveled the same distance, then the path difference will be 0. If they have traveled the same distance, your path difference is 0. That happens only at the center. Even though you get a constructive interference with path difference 0, it will not happen at R. It will happen somewhere midway between the two slits. That's somewhere here. So that's not the option. The two waves must be in phase at R. So when two waves, when they are added in phase, so now you can see they are all in phase. That means the crest of this wave 1 aligned with the crest of the wave 2. So when they are in phase, then the waves, the resultant wave will be added together to form constructive interference. When they are in antiphase, then they will cancel to form destructive interference if their amplitude are same. If they have a different amplitude, they will have a resultant wave which is smaller than one of these waves. So to have a constructive interference at this point, we know the path difference is not 0, but they will meet up in phase. So the two waves must be in phase at R. So the answer for this question is option D. Question 28. Coherent light passes through a double slit, producing bright and dark fringes on a screen placed parallel to a plane of the double slit. So we have double slit. We have coherent light passing through. Coherent light means light with a constant phase difference. When they pass through, you get fringes of dark fringe and bright fringe. The intensity of the light from each of the slits is initially the same. If the intensity is same, that means both the waves initially have the same amplitude. The intensity of the light passing through one of the slit in a double slit is now increased. Now they have increased one of the intensity. That means they have increased the amplitude of one of the waves. The frequency remains constant. What is the effect on the appearance of the fringes on the distance? On the screen. So separation of the fringes will not change due to the intensity. It will only change when there is a change in the distance between the slits, or if there is a distance change between the screen and the slits. So since it is about the intensity, there will be no change in the separation of fringes. So the answer should be either C or D. So A and B is not the choice. Now what happens to the maximum intensity of the dark fringe? Dark fringes occurs when they meet at antiphase. So for example, if you have one wave meeting this way, the other wave will have to meet. So they cancels out. But now what happened? One of the wave has a higher intensity. That means amplitude is increased. Now, when your amplitude is increased, even when you subtract both the amplitudes, they will not cancel out. They will have a very small amplitude. So it's not purely a dark fringe. Your dark fringe will become less dark, or you can say your dark fringes have become brighter. So here you can see the maximum intensity of the dark fringe has become less dark or greater brightness. So the answer is option C. Question 29. Which diagram shows the pattern of the electric field between a positively charged metal plate and a negatively charged metal plate? We know that the electric field always moves from positive charge to negative charge. When you observe the diagram, it's moving from positive to negative. The arrow is towards the positive to negative. Here is also, it's from positive to negative. Here it's the other way around. So C and D is not the option. If they are parallel plate, they will move in straight line, but it's coming from a metal sphere. So it will come radially outwards. So the answer for this question is option B. Question 30. Before a thunderstorm, the hairs on your head sometimes stand on end. This happens due to electrostatic. A hair with mass 0.50 milligram and charge 1.0 picocoulomb is supported by the force due to an electric field. Ignore any forces other than the weight of the hair and the electric force. What is the electric field strength? Now we know that the weight of the hair is being balanced by the force due to the electric field. We need to equate the weight of the hair to the force on the electric field. So weight is W is equal to mg. Force due to electric field is equal to electric field strength. Sorry about my writing. Into the charge. So I have equated the force due to electric field strength is equal to the weight. Now question is we need to find electric field strength. In this case, E is my electric field strength, so I have to make E as the subject. It becomes mg over q. The mass of the hair is given as 0.50 milligram. So I have to convert to kilogram. So 0.50 milli is a prefix stands for 10 to the power minus 3. So now this entire value is being converted to gram. I have to convert this to kilogram. So I have to multiply by 10 to the power minus 3. Once I multiply by 10 to the power minus 3, now this is given the SI unit of mass, which is kg. And to get the weight, you have to multiply by the acceleration due to gravity, which is 9.81. Divided by the charge is 1.0 picocoulomb. Pico is a prefix which stands for 10 to the power minus 12. Now, when you use the calculator, you get your answer as 4.9 10 to the power 6 Newton per coulomb. Electric field strength means force per unit charge. So Newton per coulomb. As you can see, your answer is option C. Question 31. Two parallel metal plates 4.0 centimeter apart are at an electric potential of 800 volt to 2000 volt. Point X, Y, Z are situated in the space between the plates at distance 1.0 centimeter, 2.0 centimeter, 3.0 centimeter from the lower plate. What is the electric field strength at X, Y, and Z? Now do remember one thing, it's a parallel plate. Now if it's a parallel plate, the electric field strength always remains constant. And you can find the electric field strength using this formula, the potential difference divided by the distance between the plate. So no matter the charge is at X or Y or Z, a point, these X, Y, Z will have the same electric field strength. To find the electric field strength, you need to know the potential difference. 2000 minus 800 volt will give me the potential difference, which is 1200. The distance between the plate is 4.0 centimeter. You get to convert it to meter, which is 0.04. So we get the answer as 30,000, which is 3 into 10 to the power 4. You can say volt per meter or Newton per coulomb. Any unit is fine. Since they have mentioned it, it's volt per meter. I have written it here as volt per meter. So 3 into 10 to the power 4 at X, at Y, at Z. It's going to remain the same. So the answer for this question is option C. Question 32. The potential difference V across a filament lamp is slowly raised from 0 to its normal operating value. So they are increasing the voltage of a filament lamp from 0 to its operating value. Which graph represents the variation with V of the current I in the lamp? You should know one thing. When the potential difference across a filament lamp is increased, then the current also increases. If current increases, the energy dissipated as heat will also increase. So if heat is increased, then the temperature is increased. Temperature is increased means resistance of the filament lamp is increased. Now, if I see the gradient of this graph, if I say gradient of this graph is I over V, which is reciprocal of the resistance. Now we know that the resistance increases due to the increase in temperature. Now the reciprocal of resistance is that the gradient will decrease. When resistance increases, gradient decreases. Now we need to see which graph decreases the gradient. Now we know that when there is no potential difference, there will be no current. So the graph should start from origin. So it's either A or B, or you can say it's D. Now this C is not the option. Since the graph in question option B is a straight line, it shows it's an ohmic conductor where the resistance is kept constant because the temperature remains constant. But in a filament lamp, temperature increases with an increase in current. As a result, resistance also increases. So since this corresponds to a constant temperature graph, option B is not the answer. Now, out of the choice A and D, you need to choose in which the gradient is decreasing. The easiest way to find is take 2 points. Just try to draw a tangent across this. Tangent is a point that a tangent is a straight line that passes through one point. You cannot draw it properly here, but you can see the gradient of these tangent is decreasing in this case. If you draw tangent here, the gradient at this lower point is lower, the upper point is greater. So the gradient is increasing here. If the gradient is increasing, resistance is decreasing. That's completely wrong. We need to find a graph that increases the resistance, which means decreases the gradient. So here you can see the slant is decreasing. So the answer for this question is choice A. Question 33. Two lamps are connected in series to a 250 volt power supply. One lamp is rated 240 volt, 60 watt, and the other one is rated 10 volt, 2.5 watt. Which statement most accurately describes what happened? Since they are in series, when you add 240 volt plus 10 volt, it gives you the power supply. So the power supply gives the maximum amount of voltage required by these two bulbs. Now, since they are in series, they should get the same amount of current. If power is given, power is equal to VI. If we need to find the current, take the power divided by the voltage. Now, in this case, 60 volt divided by 240 will give you 0.25 ampere. Similarly, if you divide 2.5 divided by 10 volt, you still get 0.25 ampere. That means since the same current passes through both these lamps and they get the maximum amount of their required voltage, they work with normal brightness. Let's see which one is the correct option. Both lamps light at less than their normal brightness. Completely incorrect. Both lamps light at their normal brightness. Yes, same current passes through. During that time, they are getting their maximum voltage required by the lamps. So this is the correct option. Only the 240 lamp lights if they are in series. If one of them doesn't light, the other one will not work. So this is completely wrong. The 10 volt lamp blows. No, because it gets the correct amount and it doesn't get more voltage than required. So that's incorrect. Therefore, the correct answer for this question is option B. Question 34. Which equation is used to define resistance? Resistance definition comes from the Ohm's law where we proved V is equal to IR. And from here, we can conclude resistance is equal to voltage per current. So this is a formula for energy. It doesn't come from energy. Potential difference is equal to current into resistance. Yes, it comes from the Ohm's law. Power, these are derived equations. It's not the answer. This is for resistivity. It's not the option. The correct answer for this question is option B. Question 35. The charge that a fully charged 12-volt car battery can supply is 100 kilocoulomb. So a fully charged 12-volt battery can supply 100 kilocoulomb. The starter motor of the car requires a current of 200 ampere for an average period of 2.0 seconds. The battery does not recharge because of a fault. What is the maximum number of times the starter motor of the car can be used? To find the number of times we can use the starter motor, we need to find the amount of charge a starter motor can produce for current of 200 ampere for a period of 2 seconds. We know the charge is current into time, which gives us 400 coulomb. How many 400 coulomb added together will give us 100 kilocoulomb? That will give the maximum number of time. So take the 100 kilocoulomb, kilo is a prefix 10 to the power 3, divide by 400 coulomb, you get 250 times. We can use 250 times the starter motor. So the option for this question is D. Question 36. A potential divider circuit is formed by connecting a battery of negligible internal resistance in series with two variable resistors. So we have two variable resistors, Rx and Ry, and the potential difference across the resistor Rx is Vx. Rx and Ry are both changed at the same time. Which combination of changes must cause Vx to increase? We need to increase the value of Vx. For that, what do we have to do? We have to increase the resistance of Rx and Ry, and what we have to do with Rx and Ry, whether we have to increase or decrease the resistance Rx and Ry. So for potential divider, we have this formula. If we want to get a higher output voltage, we need to increase its correspondence resistance divided by the sum of the resistance in series into the EMF of the power supply. Now, since you want to increase the voltage Vx, we need to increase the resistance Rx. Now, if voltage is increased for Rx, then Ry will anyway decrease in voltage, then only the sum of them will give the power supply. So in order to have an increased Vx, we need to increase our resistance X. And obviously Ry, we have to decrease to give a least value for the voltage across Ry. So it should be smaller. And therefore the answer for this question is option B. Question 37. In the circuit shown, contact may be made at any point along the 3 ohm resistor. It's a potentiometer. The battery has an EMF 9 volt, negligible internal resistance. What is the maximum range of the output voltage? This is a potentiometer, so you can move up to here to here. If you want to get a minimum value, you keep it here. So where the output voltage only corresponds to 2 ohm. If you want to get a maximum value, keep it here where the output voltage corresponds to 2 plus 3, which is 5 ohm. In order to get the range of values, the minimum output, to get a minimum output, you need to take 2 ohm, in which you will have the potentiometer dragged to this end. 2 ohm divided by the total resistance, 2 ohm plus 3 ohm plus 4 ohm, 9 ohm, into the EMF of the battery, which is 9 volt, will give you 2 volt. When it's maximum, you need to have this one towards here where you can calculate. Consider the entire resistance, 5 ohm divided by the combined 9 ohm into the EMF of the battery, which is 5.0 volt. So the range the output can have is 2 to 5 volt. So the answer for this question is option D. Question 38. A gold nucleus undergoes alpha decay. What are the nucleon number and proton number of the nucleus formed by this decay? So we have gold nucleus. When it undergoes alpha decay, alpha is a helium nucleus which has a charge of +2 and a nucleon number of 4. So in order to get the daughter nuclei, you will subtract your nucleon number 185 from 4, 4 from 185, and your proton number 2 from 79. The final answer is 181 and 77. So the answer is nucleon number 181, proton number 77. Answer to this question is option C. Question 39. Which row gives the correct classification of proton, electron, and neutrinos? So we have two terms, hadrons and leptons. The numerous types of particles are placed into two main categories. Those affected by strong force are called hadrons. So hadrons are examples are protons and neutrons. And those not affected by strong forces are called leptons. Example is electrons and positrons. So you can see here, proton is an hadron, electron is a lepton, neutrinos is a lepton. So you can see the option for this question is answer B. Question 40. Which equation represents beta plus decay? In order to get a beta plus decay, we need to take a proton. A proton splits into a neutron and positive electron, which is called as positron, and it will give you neutrino plus energy. So this corresponds to the positron. If it is a beta negative, it's one neutron splits into proton and electron, and that electron comes out from the nucleus as beta negative. Now the question is about beta positive decay. So that comes from a proton being split into neutron, then it converts to plus positron. Now positron is an antimatter. It will always come with a matter. In this case, matter is neutrino. So the answer for this question is option D. If you find this video helpful, like this video. To stay up to date with the latest videos and explanations to past papers, subscribe to my channel Learners Club and press the bell button to get notified with new videos. See you on the next video. Bye-bye.